The universe is under no obligation to make sense to us. It presents us with phenomena so strange, so unexpected, that they challenge the very limits of our scientific understanding. These are not failures of science, far from it. They are invitations. They are the tantalizing whispers from the cosmos that beckon us forward, urging us to question, to explore, and to imagine. What happens when our most powerful instruments detect something that defies all our neat and tidy explanations? We find ourselves standing at the edge of a great unknown, a frontier brimming with mystery and the profound wonder of discovery. These moments are the lifeblood of scientific progress, pushing us to build better tools, think bolder thoughts, look at the heavens with fresh eyes. Deep in the constellation Cygnus, nearly 1,500 light-years away, lies a star officially known as KIC 8462852. But it is more famously known as Tabby's star, named after astronomer Tabitha Boyajian, who led the initial study. This star captured the world's imagination because it does something utterly bizarre. It dims. While stars often dim when a planet passes in front of them, those events are tiny, regular and predictable. Tabby's star, however, dims erratically and dramatically. Its light has been observed to dip by as much as 22%, an enormous amount that cannot be explained by a simple orbiting planet. The pattern is chaotic, with no discernible rhythm to the deep fades. The initial data, gathered by the Kepler Space Telescope, was so strange that it sent shockwaves through the astronomical community. What could possibly block out a fifth of a star's light in such a messy, unpredictable way? The first and most sensational hypothesis to make headlines was the idea of an alien megastructure. This concept imagined a vast swarm of technology, perhaps giant solar collectors, built by an advanced civilization to harvest the star's energy. While it's a thrilling thought, science demands that we exhaust all natural explanations first, and this is where the real detective work began for astronomers trying to solve this perplexing celestial case. A more plausible, though still unconfirmed, leading theory involves a massive swarm of comets or interstellar dust. Perhaps a planetary collision in the star's system created a gigantic, uneven cloud of debris that now drifts in front of the star from our point of view. Another idea suggests that the star itself might have intrinsic processes that cause it to dim and brighten, though the physics for such behavior is not well understood. What makes this so puzzling is that different types of light dim by different amounts, suggesting the blockage is not a solid object, but something more complex, like dust, which blocks blue light more effectively than red light. In 2017, humanity received its first confirmed visitor from beyond our solar system. An object, later named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first, streaked through our cosmic neighborhood. Detected by the Pan-STARRS telescope in Hawaii, it was immediately clear this was no ordinary asteroid or comet. Its trajectory was hyperbolic, meaning it was moving too fast to be captured by the sun's gravity. It was on a one-way trip, destined to enter our solar system and then leave, never to return. Its properties were unlike anything we had ever seen before, sparking intense debate and speculation that continues to this day. What made Oumuamua so strange? First, there was its shape. Based on how its brightness varied as it tumbled through space, astronomers deduced it was highly elongated, perhaps 10 times longer than it was wide. Like a cosmic cigar. A flat pancake. Second, it lacked a coma, the fuzzy cloud of gas and dust that typically surrounds a comet when it gets near the sun. Yet, despite having no visible signs of outgassing, it exhibited a slight non-gravitational acceleration. It was speeding up, just a little, as if something other than the sun's gravity was giving it a gentle push. This combination of features, a strange shape and unexplained acceleration, made it a true scientific anomaly. Scientists scrambled to explain the visitor's peculiar behavior. Imagine a flash of light so powerful that for a few thousandths of a second, it outshines entire galaxies. Now imagine this flash is not in visible light, but in radio waves. This is a fast radio burst, or FRB. First discovered in 2007 in archival data, These are one of the most energetic and puzzling phenomena in modern astronomy. These bursts are incredibly brief, lasting only a few milliseconds, yet they release an immense amount of energy. They travel for billions of light-years across the cosmos to reach our radio telescopes, carrying with them a story about their violent origins that we are only just beginning to decipher. The mystery of FRBs deepened when astronomers discovered that they come in two flavors. Some are repeaters, flashing multiple times from the same location in a distant galaxy, while others appear to be one-off cataclysmic events. Scientists are racing to pinpoint their sources, using arrays of telescopes to triangulate their positions on the sky with increasing precision, hoping to catch their host galaxies and solve the puzzle. The leading suspect, especially for the repeating FRBs, is a type of neutron star called a magnetar. Magnetars are the most magnetic objects known in the universe. The stories of Tabby's star, Oumuamua, and fast radio bursts are not admissions of scientific failure. They are emblems of science at its best, confronted by the unknown, driven by curiosity, and relentlessly pursuing evidence. These mysteries do not create walls. They open doors to new fields of inquiry. They prevent dogma from setting in, and remind us that our current understanding is just one chapter in a much longer book. The search for answers pushes technology to its limits and inspires a new generation of scientists to join the quest. Science is not a collection of facts, but a process of discovery. It is a fundamentally human endeavor, characterized by wonder, persistence, and the courage to say, "I don't know, but let's find out." The limits of our knowledge are not a cause for despair, but a reason for hope and excitement. Our magnificent challenge, and our greatest privilege, is to keep listening, keep questioning, and never lose our profound sense of wonder at the grand unfolding mystery of it all.